Hello Algebra 2. Today we're going to be taking a look at section 6.5, which is the unit circle approach and the properties of the trig function. So what is a unit circle? A unit circle is a circle of radius 1 with center at the origin. So drawing a unit circle, it will look something like this. Here I'm going to label this 1 and label this 1 just so we're clear that it has radius 1. And if you remember from when we learned conics, this would be the equation of a circle centered at 0, 0 with radius 1. Let's go right into why the unit circle will be so useful when it comes to evaluating trig functions at different angles. So once again, I'm going to draw another unit circle. Make this one a little bit bigger. Let me label this 1 and 1. And what I'm going to do here is I'm going to draw my angle theta in standard position. If you remember standard position, that just means the vertex is at the origin. The initial side is on the positive x-axis. Here I'm going to draw my angle such that theta lies in quadrant 1. And what we're going to do is we're going to look at the point of intersection between the terminal side and the unit circle. So for now, let me just call this point x comma y. And we're going to take a look at this right triangle here that's formed. So when you look at this right triangle, the hypotenuse has length 1 because that is the radius of the circle. We know that this leg right here has length x, and we know this longer leg here has length y. What we're going to do is we're going to define the 6 trig functions in terms of the point x comma y. If you remember Sohcahtoa, we learned this acronym to help us remember what sine, cosine, and tangent of an angle was. So for sine theta, that would be opposite of hypotenuse, which is just y over 1, or just y. Cosine of theta would be adjacent of hypotenuse, which is x over 1, or just x. Tangent of theta would be opposite of adjacent, which is y over x. Here, because we have a fraction, we need to make sure that x cannot equal 0, otherwise it would be undefined. Cosecant of theta would be the reciprocal of sine, so that's just 1 over y. And once again, it has that restriction where y can't equal 0. Secant is the reciprocal of cosine, so 1 over x, where x can't be 0. And then cotangent of theta is x over y, where y cannot equal 0. So the big idea here, though, is that sine of theta is really just the y coordinate of that point. And cosine of theta is really just the x coordinate of that point of intersection, right? That the terminal side of the angle makes with the unit circle. And so this idea is going to be very useful for today's lesson, where the x coordinate is really going to be cosine of the angle theta, and the y coordinate has a value of sine of theta. And if you know that cosine of theta is the x coordinate and sine of theta is the y coordinate, you can easily find the other 4 trig functions using your identities that we learned in the previous lessons. Here I'm just going to draw another unit circle. We're going to be drawing a lot of unit circles today, so get ready for that. Draw a random angle theta in standard position. This time it will lie in quadrant 2. And this point right here, we just learned, has an x coordinate that really is cosine of theta, and has a y coordinate that's really just sine of theta. And so this understanding of the points on the unit circle and how the x coordinate corresponds to cosine of theta and the y coordinate corresponds to sine of theta will make it so much easier when you're trying to evaluate the trig functions at quadrantal angles. If you remember, quadrantal angles are angles where the terminal side lies on the x or y axis, angles like 0, 90, 180, 270 degrees, or 0, pi over 2, pi, 2 pi, 3 pi over 2 radians, those kind of angles. Let's get a couple of examples. So if you're still having trouble picturing angles in radians or drawing such angles, you should use a unit circle to help you better see what these angles look like. Let's look at another unit circle. Now imagine starting at the point 1, 0, and then making one revolution around the unit circle going counterclockwise. so you stop right where you started. What's the length of that arc that was formed? That's just the circumference of the circle, right, which has length 2 pi. Now look at the angle in standard position that's formed. I'd go counterclockwise. That would be my angle theta. Now do you notice that that angle theta is really just 2 pi radians? Right, one complete revolution. So what we notice here is that the distance that we travel around the unit circle corresponds to the angle in radians that is created. And what's nice about this is if you can picture what 2 pi looks like, and they ask you what is cosine of 2 pi, well, we know cosine of 2 pi is just the x coordinate here. And I know sine of 2 pi is the y coordinate, which is just 0. And so you can easily find cosine of 2 pi and sine of 2 pi just by picturing the unit circle, and in particular looking at the point 1, 0. Let's look at another example. So let's draw another unit circle. Again, we're going to be starting at the point 1, 0. Now imagine this time you only move halfway around the circle. So if I start at 1, 0 and I move halfway around the circle, I will stop right here, right? The point that I will stop at is negative 1, 0. Now if you notice, what's the length of that arc that was formed? Well, that would just be half the circumference of a circle, or half of 2 pi. And so that arc length is just pi. Now take a look at the angle that's formed in standard position. Let's call that theta. Do you notice that theta in this case is just pi radians, which is, if you remember, equivalent to 180 degrees. So from here we can use the fact that, okay, if I want to find cosine of pi now, I'm just going to look at this point right here. And I know that cosine of pi is going to correspond to the x coordinate of the point on the unit circle. And I know that sine of pi will correspond to the y coordinate of the point that lies on the terminal side of that angle. And you can easily find sine and cosine of another quadrantal angle. So let's draw another unit circle. This time I'm going to move only a quarter distance around the circle. So I'll stop right here, corresponding to the point 0, 1. If you look at the length of this arc, it will just have length pi over 2, because that's just 1/4 of the circumference of a unit circle, right? Now, if you look at the angle that's formed here, again in standard position, this angle here, theta, is just pi over 2 radians, which is equivalent to 90 degrees. And now if you want to find cosine of pi over 2, all we're going to do is take a look at this point right here, and we know that cosine corresponds to the x coordinate of the point on the unit circle, and we know that sine of pi over 2 corresponds to the y coordinate of the point on the unit circle, and we can easily find cosine of pi over 2 and sine of pi over 2. So hopefully you notice that the distance that we travel around the unit circle corresponds to the angle in radians that's created. And so this is just 2 pi, we're at 1 revolution. Pi radians is just traveling halfway around the unit circle, which is equivalent to 180 degrees. And pi over 2 would just be 1/4 of a unit circle, which is just 90 degrees. And so just understand that the distance that we travel around the unit circle corresponds to the angle in radians that is created, and how the x coordinate corresponds to cosine of the angle, and the y coordinate corresponds to sine of the angle. And so this idea is something we're going to be using quite a bit throughout this unit. So let P be a point on the circle x squared plus y squared equals r squared that is also on the terminal side of an angle theta in standard position. Evaluate the 6 trig functions of theta. So this is more of a review problem, not so much what we're learning about right in this particular section. So here I have a circle of radius r, and I have a point, this is not drawn to scale, let me call this point -3, 1. And I know that when I draw my angle theta in standard position, you want to make sure that the terminal side of theta goes through that point -3, 1. and let me call this here theta. And what we're going to do is we're going to look at this right triangle that's formed, because that's the triangle that we're going to be using to evaluate the 6 trig functions of theta. So looking at this right triangle here, this leg here has length 3. This has length 1. If we use Pythagorean theorem, we can do a squared plus b squared equals c squared, where c is the length of the hypotenuse. If you simplify, you get c equals square root of 10. And then from there, we're going to evaluate the 6 trig functions. So if you remember, we define sine of theta to equal y over r, right? When we define this trig function in terms of the point x comma y and r, which was the distance between the point and the origin. So in this case, sine of theta would just be 1 over square root of 10, which if you rationalize becomes square root of 10 over 10. We're in quadrant 2, by the way, and if you remember this ASTC, I'm expecting sine to be positive in quadrant 2. If I do cosine of theta, that would be x over r, which in this case would just be the x coordinate, which is negative 3 over square root of 10. And if you rationalize that, you do get negative 3 rad 10 over 10. And no surprise there, cosine should be negative in quadrant 2. To find tangent of theta, we just take y over x, which in this case would be 1 over negative 3, or just negative 1/3. Tangent should be negative since theta lies in quadrant 2. And then from there we can find cosecant of theta, which is just the reciprocal of sine, which is just square root of 10. Secant of theta, which is the reciprocal of cosine, which is negative square root of 10 over 3. And then cotangent of theta, which is the reciprocal of tangent, which is negative 3. And so the big idea in this first video is that the unit circle is a circle of radius 1. And you can use a unit circle to find the trig functions of different angles, where you look at the x coordinate, and that's going to correspond to cosine of the angle, and the y coordinate will correspond to sine of the angle. If you ever forget which one comes first, you can always recreate it yourself, right, by just using the basic definition of the 6 trig ratios. You can also remember the fact that alphabetically x comes before y, just like the c in cosine comes before the s in sine. But in the end, understand the unit circle. We'll be using the unit circle some more in the next lessons.